We began this journey deep in an ancient forest, where fungal networks process data through living threads. We soared with birds navigating by quantum effects, dove into the computational coral reefs, and witnessed the algorithms of desert survival. We scaled mountains to see Earth's grandest calculations. Now, at last, we understand, these aren't separate systems. They're all parts of a single, planet-spanning computation that has been running for billions of years. At this moment, somewhere in Silicon Valley, engineers are struggling to keep a data center cool. Yet here in the Amazon rainforest, billions of leaves are performing sophisticated quantum calculations at room temperature. While our best networks strive for 99.9% uptime, nature's systems have been running continuously since the first cell divided. Consider the scale. Every second, a single leaf performs more quantum computations than our most advanced computers. Multiply that by every leaf on Earth. Add the neural computations of every insect, bird, and mammal. Factor in the chemical calculations in every drop of ocean water, the genetic algorithms running in every microbe, the climatic computations in every cloud. The numbers become astronomical. But it's not just about scale. Watch this butterfly as it lands on a flower. In those few seconds, it solved complex equations of flight dynamics, processed multiple sensory inputs, analyzed chemical signatures, and made precision adjustments that would challenge our best autopilot systems. And it does this all while consuming less power than a digital watch. The brilliance of nature's computation lies in its efficiency. While we separate our computers from their environment, nature integrates computation into the very fabric of existence. Every atom, every molecule, every cell is part of the process. A field of grass isn't just calculating how to optimize for sunlight, it's using the results of those calculations to build the solar panels that power further calculations. Look up at the clouds gathering overhead. Each droplet is solving fluid dynamics equations. Each lightning bolt is computing the path of least resistance. The entire storm system is processing meteorological data across multiple scales simultaneously. Our weather simulations can approximate these calculations, but nature performs them with perfect accuracy in real time. Now, look closer, at the soil beneath your feet. In a single handful, billions of microorganisms are running genetic algorithms, optimizing their chemical processes, sharing data through molecular networks. This isn't just evolution, it's iterative computation on a massive scale, testing solutions to environmental challenges and preserving the successful results in DNA. The implications are profound. For decades, we've been trying to build better computers by isolating them from the natural world. But nature shows us a different path: integration rather than isolation, collaboration rather than competition, efficiency through harmony rather than brute force. As night falls, the computational dance continues. Bioluminescent organisms signal through the darkness, running communication protocols that make our own networks look primitive. Nocturnal animals process navigational data through neural networks tuned by millions of years of evolution. Even the trees adjust their chemistry, running complex optimization algorithms to prepare for the coming dawn. This is the greatest lesson of our journey: computation isn't something humans invented. We simply discovered one way to harness a process that has been running since the beginning of life itself. Every ecosystem is a supercomputer, every organism a processor, every interaction a calculation in nature's endless algorithm. As we face the challenges of the future, climate change, sustainable computing, artificial intelligence, perhaps it's time to look more closely at nature's solutions. How do forests maintain vast networks without central control? How do coral reefs coordinate billions of individuals across oceanic scales? How do desert organisms compute solutions for survival in extreme conditions? The answers could revolutionize technology. Imagine computers that, like leaves, perform quantum calculations at room temperature. Networks that, like fungal systems, self-repair and adapt. Materials that, like desert plants, compute optimal configurations for any condition. Not by conquering nature, but by learning from it. Dawn breaks on our final morning, and with it comes a new understanding. We're not separate from nature's grand computation, we're part of it. Our technology isn't an alternative to natural systems, but an extension of them. Perhaps our role isn't to replace nature's computers, but to better integrate our own computational systems into the living algorithms that surround us. As the sun rises on a new era of computing, the lessons of digital wilderness light the way forward. In every forest and reef, every desert and mountain, nature shows us computation in its most elegant form, sustainable, resilient, and breathtakingly beautiful. Our journey ends here, but nature's computation continues, in every cell, every organism, every ecosystem. We're not just observers of this process, we're participants in it. And perhaps our greatest achievement will be learning to harmonize our technology with nature's own algorithms, joining our human computations with the grand calculation that is life itself. Series End. The code of life surrounds us, runs through us, shapes our world in every moment. Now that you've seen it, you'll never look at computation, or nature, the same way again.